All right, welcome everyone to Basic Electronics and Electricity. This is voltage explained and a few other really basic electronics concepts. This was prepared by me based on the NEETS Volume 1, Chapter 1. This is for any electronic technician in the U.S. Navy that's looking to study for their rating exam. It's also for anybody who just has an interest in electricity or electronics that would like to learn a little bit more about it. So we're going to go ahead and start talking about voltage. If we were going to measure something, how much an electrical charge something has, that would actually be measured in a coulomb, which is named after a French physicist that did a lot of work with electricity. But that's not really useful to us because how much of a charge something has isn't nearly as important as how much of a charge it has relative to something else. And so that how much of a charge something has relative to something else is known as a voltage, and that's the difference in potential, and that's really what's going to be important to us. So to explain, basically what voltage is, I like to use this analogy right here of having two tanks of water. And so my tank over here on the left, tank A, has a lot of extra electrons in it. And tank B, while it does have some electrons in it, it doesn't have as many as what tank A has. And we also have a little hose and a valve in the middle there. So how do we measure that difference? We measure it in volts, and we use kilovolts to mean something that's 1,000 volts or some kind of very large number of volts, like 20,000 volts or 30,000 volts. We also use millivolts to mean 1,000th of a volt. So if we're measuring a really small voltage, then we're going to measure that in millivolts. And so 1 kilovolt equals 1,000 volts, and 1 millivolt equals 1,000th of a volt. So I have an interactive problem here. So what does 2.1 kilovolts equal to in volts? Now remember, each kilovolt is 1,000 volts, so we could go ahead and just times 2.1 kilovolts times 1,000, or you could just move the decimal place over 3 points there, and you would get 2,100 volts. So how do we make voltage? There's 6 different ways that you can make voltage, and the first one you're probably familiar with when shocking your friends. You rub your feet against the ground, against the rug while you're wearing socks, and you touch your friend and you make a little zap there. That's friction creates that voltage there. You can also create voltage using pressure, like using little crystals pressed together. That's known as piezoelectricity. That's pretty common in things like microphones and other applications like that, where you have to generate a small voltage based off of a pressure. You can also generate voltage with heat by using metals with different properties and putting them together and heating them up. That's most common used in temperature measuring devices, because you can actually measure a much higher temperature than what you would be able to measure with using a mercury-based thermometer. You can also generate voltage with light, just like solar cells you've probably seen around somewhere on top of a building or somewhere. And then also with chemical action, which would be things like batteries and stuff like that. You could also actually use a potato to create a small amount of voltage. And then also the biggest source of voltage that we use in our daily life is magnetism. And using magnetism, you can both take mechanical energy and turn it into voltage, or you can take voltage and turn it into mechanical energy. So anything like the ceiling fan at your house, or the wind farms out on the hills maybe nearby your house, they're taking that wind energy and using magnetism to convert it into an electrical voltage, and then send that to your house to power your ceiling fan. So looking back at our analogy here, so we've defined voltage as that difference in potential between tank A and tank B. So now, what's the rate that voltage, or that difference there equalizes, or what's the rate at which the liquid flows from tank A into tank B? We know that as current, and current is measured in amperes, or also we call it amps. 1 ampere is quite a bit, so typically we use milliamps to measure amps. So another interactive problem here, we have 350 milliamps. How many amps is that? We can do basically the reverse of what we did before with the kilovolts to volts, because this is a smaller thing. So basically what we're going to do is move that decimal place over 3 positions to the left, and that'll give us 0.35 amps. So we have our voltage and our current, and now there's one other really important part to this puzzle here, and that's the resistance. So that would be symbolized by that little valve that's sitting there in the middle. That's regulating basically what our current is. So our resistance is measured in ohms. You also use the little omega symbol to represent it. The resistance of any material is determined by the physical structure of the material. So if you look at this picture that we have down here at the bottom, we have picture A and picture B. In picture A, the atoms are really close together, and from that picture you can see it's a really short trip for those electrons to jump from one atom to another atom and then on to the next one after that if they're just as close. And then in picture B, it's kind of a longer trip for those atoms. It's a little bit more difficult for those atoms to jump from the electrons to jump from one atom to the next. So other things that affect resistance would be the length of your whatever it is that it's traveling through. Like if you have a piece of wire, there's a really long piece of wire, then there's a lot more basically friction inside of there for it to you could lose it can be turned into heat over the course of that that piece of wire, and you can lose voltage that way, or basically just it increases the resistance. Also the cross-sectional area of the the wire, the conductor, is going to affect that. If we look back at our example here, if you were to increase the size of that pipe in the middle, then you would end up with a greater flow of electricity from one point to the next point. And so that's basically saying the same thing as the cross-sectional area, making that larger. Temperature is also going to affect it. Temperature can affect it differently depending on what the kind of material is. Generally, most things have a positive temperature coefficient, which means basically as you increase the temperature that you're going to also increase the resistance. Conversely, you're going to decrease the temperature, then you'll decrease the resistance. However, some materials like carbon actually have a what's known as a negative temperature coefficient, which means that as you increase the temperature, it's actually going to decrease the resistance in that. And then we also have the conductance of the material itself, which is not really that important to us as an electronics technician. Maybe if you're an engineer, you might be a little bit more worried about that. But we're going to go ahead and go on to Ohm's law, which is really what this is all leading up to. I wanted to show you how everything is relative there. As you could see in that picture with the, we have our two tanks of liquid and then the little valve and the line in between it. Anything that you do there is going to affect the other things. If you increase the amount of liquid in tank A, then that's going to basically make more pressure there. It's, more voltage. So that's going to increase your current. If you increase the resistance by tightening down that valve and making it so that there's less room for that water to go through, then you're going to have less current going in through there. So basically all these different things are relative. So we can use Ohm's law, which I learned it as E equals I times R. You could write out voltage as either V or E. But basically know that all these things are relative. So if you end up with knowing what your voltage is and what your resistance is, then based on just those two things, then you can figure out what your current's going to be by taking the voltage and dividing it by the resistance. Also if you know what the current is, then you could find the voltage if you know what the current and the resistance is by timesing the current by the resistance, and that'll give you what the voltage is, which is really useful if you're trying to figure out at a certain point in an electronic circuit what should your voltage be. You can figure out based on what the current and the resistance should be, and then that'll give you that. So that was a really basic introduction to electricity there. We'll cover more in-depth stuff in later lectures, but if you have any questions on that, go ahead and leave a comment and we'll try and get your question answered. And good luck on your exam, and good luck on your endeavors there and working with electronics.